Let's look at the next property. The next property is multiplication by t, okay, or also called as the frequency differentiation theorem, okay. According to this property, it states that if the Laplace transform of f of t is equal to f of s, then this is the property. The Laplace transform of t into f of t, where t denotes the time. When the time t is multiplied with your original function, then this is equal to minus of d by ds of f of s. That means if you multiply time in with the f of t signal, it is equivalent to minus of differentiating this function with respect to s. This is called as the multiplication by t because why the reason is because in the original signal is being multiplied by t, and this is also called as the frequency differentiation theorem because your Laplace transform is being differentiated with respect to the frequency s. That is why it is written this way. This is why this is called as the multiplication by t. That is, just remember like this. That is, if you see any function, okay, if you see any problem in which there is a t or t square or t cube or anything like that is being multiplied, then on the spot you should apply the frequency differentiation theorem or the multiplication by t property, okay. Look over here, the Laplace transform of t raised to n f of t is equal to minus 1 raised to n d by ds of the order of n f of s. That is a derivative in the order of n. That means n times you should differentiate it. That's what this means. Okay, minus 1 raised to n, where n is an integer, which means if it was t square, if it is Laplace transform of t square f of t, this will become minus 1 raised to 2 d square by ds square f of s. If it was t cube, it will be t cube f of t. This will become minus 1 raised to 3, which is minus 1 into d3 by ds d raised to n by ds raised to n f of s. Okay, so that means, so you from here so you can understand that if this is a even number, if n is a even number, then this will become a positive number, and all you have to do is differentiate that many number of times. Okay, if this number is an odd number, then there will be a minus in front of it, and you should differentiate it into that many times. That's what this equation actually means. This equation is very simple in order to derive, but this equation is very important when you are going to learn some of the basic functions. Let's look at this proof of this equation. So we know that the f of s, right? F of s, the Laplace transform f of s is equal to the Laplace transform of f of t, which is nothing but integral from 0 to infinity f of t into e raised to minus st dt. Okay. Now what I'm going to do is I'm going to differentiate this equation with respect to s. So how this will become? This will become d by ds, right? D by ds of f of s is equal to d by ds of integral from 0 to infinity f of t into e raised to minus st dt. Okay. Don't ever think that this differentiation and this integral will cancel each other. Okay, they will never cancel each other because this integral is with respect to t, time, dt. See, this integral is with respect to time, but the differentiation is with respect to the frequency. This is being it's derived from with respect to frequency s. So therefore, these two won't cancel each other. Okay, so what I can do is I can put this thing inside the integral. So this will become integral from 0 to infinity d by ds of, okay, f of t e raised to minus st dt. Okay, I get it like this. Okay, but if you look over in this entire equation over here, the only place where there is an s is over here, right? This is the only place where there is an s, which means this can be written as integral from 0 to infinity f of t into d by ds of e raised to minus st dt. Right? This can be written like, because this is the only place where there is an s. So all you need to do is simply derive this with respect to s. So this will become integral from 0 to infinity f of t So differentiation of e raised to minus st with respect to s is nothing but minus t, right? Minus t into e raised to minus st dt, right? This can also be written as integral from 0 to infinity, just so that you can understand. This can also be written as minus, okay? I can put a minus sign over here. Okay, this minus sign will come over here. So integral 0 to infinity, and this is t f of t. Okay, the rest of the same, e raised to minus st dt. Okay, now I need you to compare this equation with this equation. See, this is the Laplace transform of f of t. So if this is the Laplace transform of f of t, then this is nothing but the Laplace transform of tf of t, right? This is nothing but the Laplace transform of t f of t. Okay, so this is the how we derive the equation. So therefore I can say that there's a minus sign also over here, right? There's a minus sign, okay, minus sign. So this is not, therefore I can say that the Laplace transform of t f of t, okay, the Laplace transform of t f of t is equal to minus of d by ds f of s, okay. And likewise, similarly, you can also prove in the case of t square, you can also prove the same property for t cube, for same property for t raised to 4. No matter how many times you can prove the same property or over and over again, and finally at the end you will get this constant equation, okay, t raised to n. So therefore the Laplace transform of t raised to n f of t is also minus 1 raised to n d raised to n by ds raised to n of f of s, okay. Now let's do a problem based on this property, okay. And the first problem we are going to do is regarding to the basic function, that is we have not looked earlier. You need to learn the Laplace transform of t raised to n, okay. So before, I haven't mentioned about this t raised to n function, because in order to derive this function you need to first study about the multiplication by t property. That's why. So now you have, since you have now studied this, now you can find the Laplace transform of this function, okay. Now you can find the Laplace transform. So let's find it. So here we know, we already know that the Laplace transform of t raised to n f of t, right? The Laplace transform of t raised to n f of t is nothing but minus 1 raised to n d by d raised to n by ds raised to n of f of s, right? Which means here my f of t is nothing but 1, right? Here this is t raised to n into 1. So if you compare these two equations, then f of t is equal to 1. If f of t is equal to 1, then what is f of s? That is, since f of t is equal to 1, then f of s is equal to, what is the Laplace transform of 1? The Laplace transform of 1 is 1 by s. Since we are using unilateral Laplace transform, right, from 0 to infinity, then the Laplace transform of 1 is 1 by s. So in that case, the Laplace transform of t raised to n is nothing but minus 1 raised to n differentiation with respect to s in the order of n of 1 by s. F of s is 1 by s. So this is 1 by s, which means I need to derive 1 by s n times, okay. I need to derive 1 by s n times. So what is the equation of this? Deriving this 1 by s into n times, what is the equation for this? Just so let's derive the equation for you, just so you can understand it. That is, if I derive 1 by s one time, right? If I derive 1 by s one time, what will I get? I will get minus 1 by s square. Okay, agreed? Right? If I derive 1 by s one time, I will get minus 1 by s square. If I derive it two times, what does that mean? Which means I need to derive this again, right? I have to derive this again. So what will I get if I derive this again? I will get minus 1 into minus 2 by s cube, right? I will get minus 1 into minus 2 by s cube, or it's also called as 2 by s cube, right? And what if I derive it again? Let me derive it again. That is d cube by ds cube, okay, of 1 by s. How will I derive this? In order to derive this, I just derive this one more time, right? Because this I got by deriving this. So now to get this, I need to derive this one more time. So what will happen if I derive this one more time? What will I get? I will get 2 into minus 3 by s raised to 4 or minus 6 by s raised to 4. Let me derive it one more time. If I derive it in the order of 4, s raised to 4 d raised to 4 by ds raised to 4 by 1 by s. What do I get from here? That means again I just need to derive this one more time, because this I already derived 3 times, right? This I derived 1 time, this I derived 2 times, this I derived 3 times. Now if I want to derive it 4 times, I just need to derive this one more time. So to derive this one more time, what will I get? I'll get let me see, minus 6 into minus 4 by s raised to 5. Minus 6 into minus 4 is 24. So you will get 24 by s raised to 5. And it goes on. No matter whatever the value of the number of times you're deriving, you'll get this kind of an equation. So from here, I can generally say that d raised to n by ds raised to n of 1 by s, right? If you compare all these equations, you can see it is nothing but minus 1 raised to n, okay, minus 1 raised to n into, look at this over here, it is 2 times you get 2, 3 times you'll get 6, 4 times you'll get 24, which means it's nothing but n factorial. N factorial by, if it is 1 time you'll get s square, if it is 2 times you'll get s cube, if it is 3 times you get s raised to 4, if it is 4 times you get s raised to 5, which means if it is n times you'll get s raised to n plus 1. This is the equation. Or in other words, the Laplace transform of t raised to n is nothing but minus 1 raised to n into, again minus 1 raised to n into n factorial by s raised to n plus 1. Okay, what is minus 1 raised to n into minus 1 raised to n? Minus and minus will cancel each other. You will get 1 raised to n into 1 raised to n, which is 1 itself. So therefore, I can now say that the Laplace transform of t raised to n is equal to n factorial by s raised to n plus 1, which is an equation you can now use for your basic function. This is one of the property that you should by heart or you should study. Okay, that is the Laplace transform of t raised to n is n factorial by s raised to n plus 1. Okay, now next we will derive the Laplace transform. Find the Laplace transform of t sine 80. Okay, find the Laplace transform of t sine 80. Okay, how do you do this question? In that case, the Laplace transform, to find the Laplace transform for t sine 80, we know that the Laplace transform of t f of t is equal to minus of d by ds of f of s, right? So here f of t is sine 80. So therefore the Laplace transform of sine 80, the Laplace transform of sine 80 is nothing but, we already know this equation, it is nothing but a by s square plus a square, right? So therefore, the Laplace transform of t sine 80, the Laplace transform of t sine 80 is nothing but minus of d by ds of, this is my f of s, that is a by s square plus a square. And what is the equation, what is the answer for this? This is nothing but minus of, and derivation of this is, it will be, a is a constant, I can take it outside. So it will become, what is the derivation of 1 by s square plus a square? It is minus 2s, right? Minus 2s by s square plus a square, the whole square. So therefore you will get minus and minus becomes plus. This will become 2as by s square plus a square, the whole square. See, I was able to derive this without using the integral formula, that is without using the integral 0 to infinity f of t raised to minus st dt. Without using a formula, I was able to derive this equation. That is one of the beautiful thing about Laplace transform. That is, once if you know the property and if you know the Laplace transform of some of the basic functions, then you can find almost a Laplace transform of any function without requiring any unnecessary steps. Okay, let's find the Laplace transform of t cos square t. Okay, find the Laplace transform of t cos square t. Let's find this. Okay, so in order to find, so of course we already know, to find the Laplace transform of t cos square t, I need to first find the Laplace transform of cos square t. Okay, So we know that the Laplace transform of t f of t is equal to minus of d by ds of f of s. Okay, so here my f of t is cos square t. So I need to find the Laplace transform of cos square t. So Laplace transform of cos square t is equal to, there is no direct substitution of cos square t, right? But I do know that cos 2t is equal to 2 cos square t minus 1. So therefore I can say that cos square t is equal to cos 2t plus 1 by 2, which I can substitute over here. So because the reason why is because I know the Laplace transform of this and I know the Laplace transform of this. That is why I'm using this equation. We can't find we don't know the Laplace transform of this directly. Okay, that's why. So this can also be written as the Laplace transform of cos 2t by 2, right, plus the Laplace transform of 1 by 2. This can also be written as 1 by 2 the Laplace transform of cos 2t plus 1 by 2 the Laplace transform of 1. What is 1 by 2? What is 1 by 2 into what is the Laplace transform of cos 2t? It is nothing but s by s square plus 4 plus 1 by 2 into what is the Laplace transform of 1? It is 1 by s. Okay, so there, now I found the Laplace transform of cos square t. Now I can find the Laplace transform of t cos square t, which is nothing but minus of d by ds of this function, right? So therefore the Laplace transform of t cos square t is equal to minus of d by ds of this, that is 1 by 2. I can write it as, okay, I write it 1 by 2 s by s square plus 4 plus 1 by 2s, which means I just need to derive this function in order to find the answer. So I'll take 1 by 2, right? I can take 1 by 2 common, right? From both of this case, I can take 1 by 2 common. So this will become minus 1 by 2 into, and then it will become d by ds of, maybe I can apply d by ds inside the bracket. So in that case, it will become d by ds of s by s square plus 4 plus d by ds of 1 by s. Correct? So this can also be written as minus 1 by 2 into, here all you can do however you want. You can apply any type of derivation that you prefer, any derivation. For any derivation you apply, you will get the same answer. Okay. So what is the derivation of this? This is in the form of u by v, right? U by v. So what is the equation for derivation of u by v? It is v into du minus u into dv by v square. So v into du is s square plus 4 and du is 1 minus u into dv. U is s and dv is derivation of this, which is 2s by v square, s square plus 4 the whole square. That's the derivation of the first term. What about the second term? The derivation of this is nothing but minus 1 by s square. Okay. So this is also equal to writing minus 1 by 2 into, and this is s square minus 2s square is minus s square. So you get minus s square plus 4 by s square plus 4 the whole square, and here you will get minus 1 by s square. Okay. Now I can apply this minus 1 by 2 inside the bracket. So I will get the answer as s square plus 4 by 2 into s square plus 4 the whole square plus 1 by 2 s square. There. See? Now you can find the Laplace transform of this function. So this is how we find the Laplace transform of any function in which it is being multiplied with t. Okay. Let us do one more problem. Okay, one more problem with regards to this multiplication by t property. Here I will find the Laplace transform of t sine 2t cos h t. Okay. The reason why we are doing this much problems is just so you can you will have a general you will appreciate the importance of a Laplace transform. That is, even though you have learned the equation, you don't actually need to know the equation in order to do the Laplace transform. Once if you know all the basic properties, and once if you know all the basic functions, then you can find the Laplace transform of any complex functions without any much trouble. You see, this is a very complex signal, right? This is actually consisting of three signals. One is t, one is sine 2t, and one is cos ht. So how will I find this the Laplace transform of these three signals? See, in that case, the product of these three signals. See, in that case, all you need to do is substitute any one of them in terms of its exponential function. Any one of them. I'll choose this. Okay, I will substitute this in terms of its exponential function. So in that case, I can say that t sine 2t cos ht, right? Cos ht is equal to t sine 2t into, and what is the full form of cos ht? It is written as e raised to t plus e raised to minus t by 2, right? So which means the Laplace transform of this function can now be written as the Laplace transform of this. Okay, we know that the Laplace transform of t f of t is equal to minus of d by ds of f of s, right? This is the equation. So here my f of t is this sine 2t cos ht. So therefore the Laplace transform of sine 2t cos ht is equal to the Laplace transform of this, which is nothing but let me see, 1 by 2 Laplace transform of e raised to t sine 2t plus 1 by 2 Laplace transform of e raised to minus t sine 2t, right? So we know the Laplace transform of sine 2t, right? What is the Laplace transform of sine 2t? The Laplace transform of sine 2t is actually nothing but 2 by s square plus 4. So in that case, the Laplace transform of e raised to t sine 2t is nothing but, this is called as the frequency shifting theorem, right? So e raised to t, which means if it is e raised to t, then the value of a is minus 1. Also substitute s with minus 1. Substitute s with s minus 1. So you will get, according to frequency shifting theorem, this is nothing but 2 by s minus 1 the whole square plus 4. This is the Laplace transform of e raised to t sine 2t. Now, what is the Laplace transform of e raised to minus t sine 2t? That is nothing but replace this s. So this is according to frequency shifting property. So replace s with s minus 1. So this is e raised to minus t. So the value of a is plus 1. So replace s with s plus 1. So you'll get 2 by s, replacing s with s plus 1 the whole square plus 4. See, now I found the Laplace transform of this, and I found the Laplace transform of this. Therefore, I can find the Laplace transform of this, which is nothing but, that is the Laplace transform of sine 2t cos ht is nothing but the 1 by 2 the Laplace, let me write it, 1 by 2 Laplace transform of e raised to minus t e raised to t sine 2t plus 1 by 2 e raised to minus t sine 2t. Okay, and I already found that the Laplace transform of e raised to t sine 2t, the Laplace transform of e raised to t sine 2t is 2 by s minus 1 the whole square plus 4. 2 by s minus 1 the whole square plus 4 plus 1 by 2 into, and the Laplace transform of e raised to minus t sine 2t is 2 by s plus 1 the whole square plus 4. It is 2 by s plus 1 the whole square plus 4. Okay, so these 2 and this 2 will get cancelled, this 2 and this 2 also will get cancelled, so you will get 1 by s minus 1 the whole square plus 4 plus 1 by s plus 1 the whole square plus 4. Okay, so now I found the Laplace transform of this. Therefore the Laplace transform of t sine 2t cos h t is equal to minus of d by ds of, this is my f of s, 1 by s minus 1 the whole square plus 4 plus 1 by s plus 1 the whole square plus 4. Okay, very simple. And this is nothing but minus of, this can be written as d by ds of 1 by s minus 1 the whole square plus 4 plus, this can also be written as d by ds of 1 by s plus 1 the whole square plus 4. Okay, this can also be written as, this is minus of, so what is the differentiation of this? See, differentiation of this is, let me see, it will become s minus 1 raised to square, right? So it will become 2 into s minus 1. So it's the denominator, so it's minus 2 into s raised to. So it will be minus 2 into s minus 1 by s minus 1 the whole square plus 4 the whole square. Okay, plus over here also, here the differentiation of this is 2 into s plus 1, right? So it's in the denominator, so it will become minus 2 into s plus 1. So it is minus 2 into s plus 1, and the denominator is the whole thing square. So s plus 1 the whole square plus 4 the whole square. Okay, minus and minus will cancel, so here you will get is 2s minus 2 by s minus 1 the whole square plus 4 the whole square, and here you will get plus 2s plus 2 by, and here you will get s plus 1 the whole square plus 4 the whole square. This is your answer. See, this is the Laplace transform of t sine 2t cos ht. Okay. Now the next property is the division by t, or also called as the frequency integration theorem. Okay, so this property you are using anytime if your function is being divided by time t, just like your multiplication by t property. Multiplication by t property you are using anytime if your function is being multiplied by time t. Same way over here, this property is used anytime if your function is being divided by time t. So according to the statement, it says that if Laplace transform of f of t is equal to f of s, then the Laplace transform of f of t by t is equal to integral from s to infinity f of s ds. Okay, so that is why here's, which means if the dividing f of t by time t is equivalent to integrating f of s with respect to s. That is why it's called as the frequency integration theorem. Okay, also I want you all to remember the limits. The limits is from s to infinity, not 0 to infinity, it is from s to infinity. Okay, so let's prove this theorem. So here we all know that f of s is equal to integral from 0 to infinity f of t into e raised to minus st dt, right? We all know this. What I'm going to do is that I'm going to integrate this with respect to s from s to infinity. So this will become integral s to infinity f of s ds. Okay, this can be written as integral from s to infinity. Now I'm going to expand the term of f of s, which is this equation. Let me use another pen. This can also be written as integral 0 to infinity f of t e raised to minus st dt ds. Okay, means I just replace the value of f of t with this equation. That's all. Okay, so now I want to integrate this with respect to s. But if you look in this entire equation, the only place where there is an s is over here. This is the only place where there is an s, right? So which means this can be, means I can put this integral inside the function, and it's already it's available only over here, right? So this can be written as integral from 0 to infinity f of t, and this integral can be put inside, so this will become integral from s to infinity e raised to minus st ds dt. Okay, The reason is because this is the only place where there's an s. So if I want to integrate this with respect to s, I need to integrate only this with respect to s, because this is the only place where there's s. Here f of t dt, there's no s over here, right? That is why. So what is the integration of this? This can be written as from 0 to infinity f of t into this is nothing but e raised to minus st by minus t, and the limit is from 0 s to infinity, not 0, s to infinity dt. Okay, and this is equivalent to integral 0 to infinity f of t into, so here if I substitute the value of s with infinity, it will become e raised to minus infinity. E raised to minus infinity is 0, right? 0, so it will become 0 minus, now if I replace s with s, it will be this e raised to minus st itself. So e raised to minus st by minus t dt. Okay, so minus and minus will cancel each other, so therefore I can now say that this is equivalent to integral 0 to infinity f of t by t e raised to minus st dt. Okay, compare these two equations. If this is the Laplace transform of f of t, then this must be the Laplace transform of f of t by t. Therefore this is equivalent to the Laplace transform of f of t by t. Okay, hence proved. Okay, so now let's do a simple problem based on this theorem. Okay, using this theorem. So the first problem I will find is find the Laplace transform of let's do this question, that is 1 minus e raised to minus t by t. Okay, let's find the Laplace transform of this. Laplace transform of 1 minus e raised to minus t. Okay, so first to do this, what I need to do is first I find the Laplace transform of, we know that the Laplace transform of f of t by t, right? The Laplace transform of f of t by t is given by integral from s to infinity f of s ds, right? So therefore here my f of t is 1 minus e raised to minus t. So therefore the Laplace transform of 1 minus e raised to minus t is given by, what is the Laplace transform of 1? It is 1 by s. What is the Laplace transform of e raised to minus t? It is 1 by s plus 1. So 1 by s minus 1 by s plus 1. So therefore the Laplace transform of 1 minus e raised to minus t by t is nothing but the integral from s to infinity of 1 by s minus 1 by s plus 1 ds. Okay, this can also be written as, what is the integral of 1 by s? Integral of 1 by s is log s. What is integral of 1 by s plus 1? It is log s plus 1. So this can be written as log s minus log s plus 1 from s to infinity. Or this can also be written as, I can't substitute infinity directly over here, this is because log of infinity is undefined. So I need to change, need to make some slight modification over here. This can be also be written as log of, so we know that log a minus log b is log a by b. So this can be written as log of s by s plus 1 from s to infinity. Okay, still also I cannot, this will become log infinity by infinity, right? So I need to make one more modification. I'll make this as log of, divide both the numerator and denominator by s. This will become 1 by 1 plus 1 by s from s to infinity. Okay, now I can apply infinity over here, because if I apply infinity over here, this will become 1 by infinity, which is 0, right? So that will be a definite value. So if I substitute infinity over here, I'll get log of 1 by 1 plus 1 by infinity is 0 minus log of 1 by 1 plus 1 by s. Okay, log 1 is 0, so you will get minus of log of, this can be written as s by s plus 1, or this is equivalent to writing log of s plus 1 by s, because minus of log a by b is log b by a, right, reciprocally. So this is the answer, log of s plus 1 by s. See, so this is how we find the Laplace transform of e raised to minus at minus e raised to minus bt by t. Okay, we'll find the Laplace transform of this. So we all know that the Laplace transform of f of t by t is equal to integral from s to infinity f of s ds, right? So therefore here my f of t is e raised to minus at minus e raised to minus bt. So therefore I can say the Laplace transform of e raised to minus at minus e raised to minus bt is equal to, what is the Laplace transform of e raised to minus at? It is 1 by s plus a. Minus, what is the Laplace transform of e raised to minus bt? It is 1 by s plus b. Okay, so therefore the Laplace transform of e raised to minus at minus e raised to minus bt by t is nothing but integral from s to infinity of, this is my f of s, that is 1 by s plus a minus 1 by s plus b ds. Okay, so what is the integral of 1 by s plus a? It is log s plus a, and the integral of 1 by s plus b is log s plus b. Therefore it is limit from s to infinity. Okay, so I cannot apply infinity directly over here, so therefore what I'm going to do is that, just like before, I'm going to make this into log s plus a by s plus b. Okay, from s to infinity, because log a minus log b is log a by b, right? And here also still I cannot apply my infinity, because this will become log infinity by infinity, which is not defined. So therefore what I'm going to do is I'm going to write this in terms of 1 by s. So therefore this is nothing but log of 1 plus a by s by 1 plus b by s. Okay, from s to infinity. Now I can apply this equation. So this will become, so if I substitute s as infinity, this will become a by infinity is 0, so it will become log 1 by log 1, which is 0 itself, right? So this will become 0 minus, and if I substitute s over here, this I will get the same equation. So therefore it will become log of s plus a by s plus b. Okay, so what is minus of log of s plus a by s plus b? Is nothing but reciprocal, that is log of s plus b by s plus a. Okay, see, when it comes to this kind of a question, that is when divide by t comes, always try to do this problem in the exponential function series. Okay, so for example, if you see any trigonometric function, so if you see any hyperbolic cosine function or sine function, if you see any of these kinds of trigonometric functions, represent those functions in terms of trigonometric values in trigonometric equations, and then you find the integration. Okay, otherwise it will be very difficult for you. That's why. Okay, because in almost in all these cases, for these kind of problems, always the answers will be in terms of the log function. Okay, that's why. Okay, so now the next property we're going to take is the time differentiation property. Okay, or time differentiation theorem. It states that if the Laplace transform of f of t is equal to f of s, then the Laplace transform of f dash of t actually means nothing but df of t by dt. That is, it is nothing but the derivative of f of t with respect to time t. Okay, that's what the f dash of t means. So the Laplace transform of f dash of t is equal to s f of s minus f of 0, where this f of s represents your Laplace transform f of s, that is the same Laplace transform, and this small letter f of 0, that is the small letter f of 0, is actually the value of f of t at time t is equal to 0. Okay, which means you need to substitute the value of f of t at time t is equal to 0. Find the what is the value of f of t at time t is equal to 0 and substitute that over here. That is, this is actually called as the initial values. Okay, this is called as the initial value. So like I said, if you want to find the derivative of your Laplace transform, or if you want to find the Laplace transform of the derivative of your function, what you need to do is you need to multiply your function, your f of s, your Laplace transform with s, minus, then you need to find the initial value of f of t, that is the value of f of t when t is equal to 0, and substitute that over here. This will give you the Laplace transform of the derivative of your function. Okay, likewise, now if you look at the second equation, see also look at the how it is being written. What is the correlation between these two equations? The Laplace transform of f double dash t. F double dash t actually means the second order derivative of f of t. That is, f double dash of t means d square f of t by dt square. That is what it means. Okay, second order derivative of f of t. That is what f dash double dash of t means. So this is equal to s square f of s minus s f of 0 minus f dash of 0, where this f of s is your Laplace transform, okay, minus s f of 0. This f of 0 represents the same, the value of f of t at t is equal to 0, and f dash of 0 is the derivative of f of t at time t is equal to 0. Which means in this equation, to find the Laplace transform of the second order derivative of this function, you need to multiply your f of s with s square minus s into, you need to put the value of f of t at time t is equal to 0. Okay, then minus, then you have to put you have to find the derivative of f of t and then put time t is equal to 0. You see, so this is how the equation as it goes on. Here the main equation is that the Laplace transform of the nth order derivative of f of t. That is, if it's being derivated n times. Look how the equation is being written. That is, the first term will be s raised to n. See, if it is if it is d square by dt, it will be s square. If it is d by dt, it will be s. Likewise, if it is d raised to n by dt raised to n, it will be s raised to n. Nth order derivative. In that case, this is equal to s raised to n f of s minus s raised to n minus 1 f of 0 minus s raised to n minus 2 f dash of 0 minus, and it goes on up to the last term will be minus f n minus 1 0, where f of n minus 1 0 is the n minus 1th derivative of f of t at time t is equal to 0. So which means if you look at this equation, now you are able to write. That means how many times your function is being derived, that many times you need to multiply your f of s with that power of s. For example, if it is d cube f of t by dt cube. See, so there it's a 3. The order is 3. So it will be s cube f of s minus s square f of 0 minus s f dash of 0 minus f double dash of 0. Like that it goes. You see, that's how we'll be able to write the equations. So, but mostly in this subject, these two equations are the most commonly used. Okay, they will mostly most of the time they haven't asked any questions related to more than 2 times the second order derivation. Okay, every time a differentiation takes place only within the order of 2. Okay, so just remember these two equations. Okay, now let me prove this equation. So we all know that the Laplace transform of f of t, right, or f of s, is nothing but integral 0 to infinity f of t e raised to minus st dt, right? So which means in that case the Laplace transform of f dash t, that is f dash t is nothing but the derivation of f of t, derivative of f, is df of t by dt. Remember, this is differentiated with respect to time t. Okay, don't forget that. So Laplace transform f dash of t is nothing but simply replace f of t with f dash of t. So you will get integral 0 to infinity f dash of t into e raised to minus st dt. Okay. So now what I'm going to do is I'm going to integrate this. Very simple. How to integrate this is because we already know the equation for this. That is, we already know the integral of u dv, where u and v are functions of x. It's supposed to be u dv dx, because integrating with respect to x. That's what this equation. This is an integration formula which you have already studied, okay, in your maths class. So integral u dv is nothing but u v minus integral v dv u into v into du, okay, uv minus integral v into du. Okay, that's what this equation is. So here we'll substitute the value of u. So here u over here is nothing but e raised to minus st. Okay, u is e raised to minus st. So in that case du if u is e raised to minus st, then what is du? Du is the differentiation of this with respect to time, right? So how do you so what do you get if you differentiate this? You will get minus s e raised to minus st. Okay. Now next is dv. What is dv over here? dv is df of t by dt. Okay. dv is df of t by dt or f dash of t. F dash of t. So if dv is equal to f dash of t, then what is v? If dv is f dash of t, then what is v? V is the integral of this, right? Integral of df of t by dt is nothing but f of t itself, right? Because if this is the derivative, then this must be its integral. So now I can substitute all these equations over here. So in that case, I can now say that integral 0 to infinity f dash of t e raised to minus st dt is equal to, that is the Laplace transform of this, is nothing but, what is u? E raised to minus st. What is v? F of t minus integral, what is v? F of t. And what is du? Du is minus s e raised to minus st. Okay, dt. Okay, and the limit is from 0 to infinity. 0 to infinity. Okay, so this can also be written as, now I can apply this limit inside this bracket, so it will become limit e raised to minus st f of t from 0 to infinity minus, and here it will become integral 0 to infinity. So here there is minus s, so minus s can be considered as a constant. So minus of minus becomes plus, so I can make this plus over here, and I make this s outside the integral, so I'll put s over here. Then the rest of them will become f of t e raised to minus st dt. Right? This is how the equation will take place. So now I will substitute the value of infinity and 0 over here. So what will I get over here? It will be, here it will become e raised to minus infinity f of infinity. What is e raised to minus infinity? Is 0, right? So this will, so the first term is 0 minus, and here it will become e raised to 0 f of 0, right? E raised to 0 f of 0. Okay, plus, and what about here? Here it is s. And what is integral 0 to infinity f of t e raised to minus st dt? Integral 0 to infinity f of t e raised to minus st dt is nothing but your Laplace transform. It is nothing but your Laplace transform of f of t, that is f of s. Okay, so here this is equivalent, this is equal to e raised to 0 is 1, so it is minus f of 0 plus s f of s, right? Minus f of 0 plus s f of s, or this can also be written as s f of s minus f of 0. That is the Laplace transform of f dash of t, hence proved. Okay, this is how we prove it. So which means that is one of the another advantage of this Laplace transform. That is, you know, one of the main advantages in mathematics, from a mathematical perspective, what you must have all studied about this. You must have even done problems regarding this. That is, the main advantage is that for a differential equation, right? If you are trying to find the solution of a differential equations, for a simple order differential equations, it won't be a problem for you, right? You just need to learn how to find the homogeneous solution and the particular solution, and then from there you can find the total solution of a differential equation. But in the but if the order of the differential equation is high, for example, if it is more than 3 or more than 3, okay, in that case, that finding the solution will be very difficult. It will be extremely difficult. So in that case only, Laplace transform comes to the rescue, because Laplace transform basically, according to this property, is saying that it will basically convert this differential equation into an algebraic equation. You see, so the equation just changes perspective from a differential equation to an algebraic equation. So therefore, the Laplace transform actually simplifies that equation. That's what I said in the last class. That is, some operations which are hard to do in the time domain will be very easy when you are converting it to its frequency domain. See, so in this is one of the good examples. That is, in the differential equations in time domain is nothing but becomes a simple algebraic equation in the frequency domain. So all you need to do is simply find the solution of this algebraic equation. That's all. That is what this property actually states. Okay, so this property where you basically using any time if your function signal is being time differentiated with respect to t. Okay, differentiated with respect to t. So let's do a simple question based on this. Find the Laplace transform of f of t and the Laplace transform of f dash of t. Okay, find the Laplace transform of f of t and the Laplace transform of f dash of t when f of t is equal to e raised to minus 5t sine t. This is the question. Okay, so which means that there are two ways where you can solve this question. One way is by finding the Laplace transform of f of t and then finding the derivation of f of t and then finding the Laplace transform of f dash of t, which is a time consuming process. But now, since you have already learned the time differentiation property, this equation becomes more simple. First, what you're going to do is you're going to find the Laplace transform of this function. So what is the Laplace transform of this? We know that the Laplace transform of sine t, right? We know the Laplace transform sine t. The Laplace transform of sine omega t is omega by s square plus omega square. Therefore, the Laplace transform of sine t is 1 by s square plus 1 square, or 1. So 1 by s square plus 1. In that case, what is the Laplace transform of e raised to minus 5t sine t? This is called as the frequency shifting property, right? Which means if the exponential function is being multiplied, then it is equivalent to substituting the value of s with its shifted frequency. So here the value of a is minus 5, or a value of a is minus 5. So which means here it will become 1 by, here it will become s plus 5 the whole square plus 1. Okay, according to frequency, it's replacing s with its shifted version. That's all. So it becomes more simple. See, very simple. So very easily I found the Laplace transform of this function f of t. Now I found the Laplace transform of this function. So now the Laplace transform of f dash of t is equal to s f of s minus f of 0, right? This is the equation. So what is f of s? F of s is this function itself minus, and what is f of 0? F of 0 is this function when time t is equal to 0. So this is equal to s into 1 by s plus 5 the whole square plus 1 minus, and what is f of 0? This function, that is e raised to minus 5 into 0 into sine 0. This is it. Okay, so this is e raised to 0. E raised to 0 is 1. But what is sine 0? Sine 0 is 0 itself. So this will become 0. So therefore this is your answer. That is s by s plus 1 the whole square, s plus 5 the whole square plus 1. Okay, this is your answer. This is how we do the problem. Okay, let's do one more question. Okay, one more question in this. So here the question is, find the Laplace transform of f of t and the Laplace transform of its derivative f dash of t when, now I will tell you what is f of t. F of t is equal to t for 0 less than or equal to 3, less than or equal to t less than 3, and it is equal to 6 when t is greater than 3. This is the equation. That is, f of t is equal to t when between 0 to 3, and when t is greater than 3, f of t is equal to 6. This is the question. Okay, so they are asking us to find the Laplace transform of this. Okay, so for those, sometimes in some questions they will not give you this. Okay, they will not give you this. Instead of that, they'll give you a graph. If it is a graph, how does it look like? if this was a graph, how will it look like in that case? Here you can see f of t is equal to t. T means this is t, right? T from 0 to 3. From 0 to 3, f of t is equal to 3. And then it is, and when it reaches 6, when f of t is 6, it is constant. That is, f of t is equal to 6 for t greater than 3. So sometimes they'll give you in this form, right? They'll either give you a graph and they'll ask you to find the Laplace transform, or they'll give you the Laplace transform in terms of its definition. Okay, in two ways they can give. So anyway, so here, what is the Laplace transform of this function? It's very simple, right? So, but here, do not ever apply the Laplace transform of your unit ramp function. Okay, we all know that the Laplace transform of t is actually equal to 1 by s square. We have studied that, but you cannot apply this equation over here, because when you studied this formula, your Laplace transform equation was supposed to be integral from 0 to infinity f of t e raised to minus st. It is the limit is from 0 to infinity. If it was 0 to infinity, then this is your equation for your Laplace transform of t. Okay, but look over here. Here, the Laplace transform of t, the Laplace transform of f of t, when you are finding the equation, you cannot apply the same equation, because here it is not from 0 to infinity, only from 0 to 3. See, it's only for a limited time. Only for a limited time only the f of t act as a unit ramp function. Then after that, as it goes on, it acts as a step signal. So therefore, you cannot apply f of t Laplace transform of t is equal to 1 by s square. It's not 1 by s square over here. Which means for these kind of questions, the only way of applying the Laplace transform is by applying the actual equation. There is no shortcut method for this. Okay, so let's find the Laplace transform. So in that case, the Laplace transform of f of t. The Laplace transform of f of t, let's write the equation. It is from integral 0 to infinity f of t e raised to minus st dt. Okay, and according to your question, the Laplace transform of f of t is from 0 to 3. From 0 to 3, the value of f of t is t. So it is t into e raised to minus st dt plus, and from 3 to infinity, the value of f of t is 6 into e raised to minus st dt. Okay, this is called as the linearity property, right? So from 0 to 3, it is the value of f of t is t, and from 3 to infinity, the value of f of t is 6. You see, if it was 0 to infinity over here, then this is nothing but 1 by s square, but it is not. Okay, so we need to find the Laplace transform of this. And also we need to find the Laplace transform of this values also, right? So let's find the Laplace transform. So in this case, the only way of finding it is by writing the equation. That is, we know that integral u into dv is equal to uv minus integral v into du. Okay, and here u is equal to, u is nothing but let's choose this. U is nothing but t. In that case, what is du? Du is 1, and here dv is supposed to be e raised to minus st. In that case, then v is equal to e raised to minus st by minus s. So substitute all that over here. That is will be the first term. So this is equal to u is t. So it will be t into e raised to minus st by minus s. Okay, minus integral, and what is v? V is e raised to minus st by minus s, and what is du? Du is 1 into 1 dt. Okay, from 0 to 3. From 0 to 3. Okay, plus what about this? This is nothing but 6 into e raised to minus st by minus s from 3 to infinity. Okay, this is also equal to here I can substitute the value of 3, so I will get 3 into e raised to minus s 3s, right? 3 into e raised to minus 3s by minus s. Okay, that's over here, minus, and if I put 0, this will become 0, so forget about it, minus integral from 0 to 3 here to become e raised to minus st, and here minus or minus becomes plus, so I can make this plus s dt. Okay, plus, what about here, 6 into, if I put infinity over here, this will become 0 minus, and if I put 3 over it will become e raised to minus 3s by minus s. Okay, that is what over here. Here it will be, this is nothing but minus 3 e raised to minus 3s by s. Okay, plus, and here it will be, this is nothing but 1 by s, and this is again e raised to minus st by minus s from 0 to 3, plus, and here it is minus or minus becomes plus, this is 6 e raised to minus 3s by s. Okay, and this is equal to, and this is nothing but 1 by s square, right? This is 1 by s square, so here you will get this and this can be added together, and you will get plus 3 e raised to minus 3s by s. This is nothing but minus 1 by s square into, and here it is e raised to minus 3s minus, and 0, it will become 1, right? So this is the equation, this is your answer. Okay, so this is equal to 3 into e raised to minus 3s by s minus e raised to minus 3s minus 1 by s square. Okay, this is the equation. So I will write like this also, that is 1 by s 1 by s square plus e raised to minus 3s into 3 by s minus 1 by s square. Okay, alright, this is the equation for the Laplace transform f of t, okay, or f of s. Now I can find the Laplace transform of f dash of t. So the Laplace transform of f dash of t is s f of s, which you have already found, minus f of 0, that is the value of t, or a value of f of t at time t is equal to 0. So this is equal to, now I can multiply this with s, this will become s into 1 by s square plus e raised to minus 3s into 3 by s minus 1 by s square. That's the f of s minus, what is f of 0? F of 0 is f of t at time t is equal to 0. So what is the value of f of t at time t is equal to 0? According to your statement over here, the value of f of t at time t is equal to 0 is t, right? The value of f of t at time t is equal to 0 is t. So, and that, which means if the value of f of t at time t is equal to 0 is t, then t is equal to 0, right? So therefore this is minus 0 itself. Okay, because I hope you understood this. Why? Because f of t is nothing but f of t at time t is equal to 0. Okay, f of t is at time t is equal to 0. So what is the value of f of t at time t is equal to 0 is t. That's why it becomes t. But value of t is 0, so this is 0 itself. That's why it becomes 0 over here. Okay, so this is, so therefore your final equation will become, that is the Laplace transform of f dash of t is nothing but 1 by s, okay, multiplying this s inside, this will become 1 by s plus e raised to minus 3s into, this will become 3 minus 1 by s. Okay, this is the equation. Okay, is the time integration property. Okay, so here if Laplace transform of f of t is equal to f of s, then the Laplace transform of integral 0 to t f of t, okay, you should see the if the f of t is being integrated from 0 to t, okay, time t, not from 0 to infinity, is from 0 to t, then this is nothing but simply divide your f of s with s. That's all. Simply divide your Laplace transform by s, that is equivalent to integral from 0 to t f of t dt. You see, so basically this is also simplifying your time domain signal, right? If you are doing an operation of integration in time domain, it's equivalent to dividing your Laplace transform by s. You see, so this is one of the another advantage of Laplace transform. So let's prove this. Okay, so we know that the Laplace transform of f of t is equal to integral from 0 to infinity f of t e raised to minus st dt. Okay, in that case, then the Laplace transform of integral 0 to t f of t dt is actually equal to integral 0 to infinity. I'll use another pen just so you won't get confused. So replace f of t with this, that is integral 0 to t f of t dt, okay, into e raised to minus st dt. Okay, so again I'm going to use that same equation that you have used before, that is integrating u into dv. Alright, what is the formula? That is uv minus integral v into du. Okay, and here your u is, I'm going to use u as this function. Okay, that is integral 0 to t f of t dt, and my dv I'm going to use this function e raised to minus st. So in that case, what is du? Du is nothing but differentiation of this. A differentiation of an integral is that function itself. So you will get f of t, right? Differentiating and integration, they both, their differentiation and integration will cancel each other. So it will be a f of t. Now what about v? V is the integration of this, which is e raised to minus st by minus s. Okay. Now I will substitute all these values over here. I will get, that means the Laplace transform of integral 0 to t f of t dt is equal to integral from not integrals, it is actually, it is uv. U is this one, 0 to t f of t dt into, what is v? This is v, e raised to minus st by minus s. Okay, this is 1/2 of the answer, and this is between from 0 to infinity, right? From 0 to infinity, minus, now the second half is this one, minus integral, okay, integral, and here it will become 0 to infinity, right? Integral 0 to infinity. Now what is v? This is v, e raised to minus st by minus s, and what is du? Du is this, which is f of t dt. Okay, this is what you get. So now I'm going to substitute this equation over here. And before substituting this equation, let me just tell you how I'm going to do the substitution. I don't have to write the entire steps because it's very easy to understand. You see, so what I'm going to do is that now I'm going to apply t is equal to infinity minus this same function t is equal to 0. That's how I'm going to do this problem, right? So what happens is, so before, I'm not going to write the whole thing over here because it's very easy to understand. You see, in this same equation, what will happen if I put t is equal to infinity? Okay, this will become 0 to infinity f of t dt into e raised to minus infinity by minus s. But what is e raised to minus infinity? E raised to minus infinity is 0, which means the first term is 0. This becomes 0, therefore the first term is 0. Okay, so therefore it becomes 0 minus. Now what will happen if I put t is equal to 0? If I put t is equal to 0, this will become integral 0 to 0 f of t dt into e raised to 0 by minus s. Okay, e raised to 0 is 1. Alright, but what about over here? Like I said, if I put t is equal to 0, this will become integral 0 to 0 f of t dt. What is integral 0 to 0 f of t dt? Which means this will become f of 0 minus f of 0, right? When I am substituting it will become f of 0 minus f of 0, which is 0 itself. They both will cancel each other because we'll integration of two function. Integration of between two same limits is always the of any function, it always becomes 0. So the second term is also 0. Okay, so therefore this entire equation, this entire term, the value of this entire term is actually 0 itself. Okay, minus, here this is minus, so minus becomes plus, so this is plus 1 by s, because s I can take outside, integral 0 to infinity f of t into e raised to minus st dt. Okay, and what is integral 0 to infinity f of t e raised to minus st dt? This whole thing is nothing but f of s. Okay, this is nothing but f of s. So therefore you will get 0 plus 1 by s into f of s, or this is equal to f of s by s. Okay, so therefore the Laplace transform of integral from 0 to t f of t dt is nothing but f of s by s. Okay, now let's do some problems. So first we will do is find the Laplace transform of integral 0 to t e raised to minus 2t into t raised to 3 dt. Okay, let's do this question. Okay, so we are going to find the Laplace transform of this function. So so what I have to do is simply just look over here. There's integral 0 to t, right? So if you see integral 0 to t, immediately you should understand. Simply find the Laplace transform of this and divide it by s. That's all. So first I'll find the Laplace transform of this. Okay, so what is the Laplace transform of t cube? What is the Laplace transform of t cube? We know that the Laplace transform of t raised to n is actually equal to n factorial by s raised to n plus 1, right? Which is one of the basic functions that you should study. That is, Laplace transform of t raised to n is n factorial by s raised to n plus 1. Therefore, the Laplace transform of t cube is nothing but 3 factorial by s raised to 4. 3 factorial means 1 into 2 into 3, which is 6. So 6 by s raised to 4, which is the Laplace transform of t cube. Now in that case, what is the Laplace transform of e raised to minus 2t into t cube? That is, now you are applying frequency shifting theorem. It simply shift the value of s, or replace s with s plus 2. So this is nothing but 6 by s plus 2 the whole raised to 4. This is the Laplace transform of this. So in that case, the Laplace transform of integral 0 to t e raised to minus 2t t cube dt is nothing but 6 by s into s plus 2 the whole raised to 4. That's it. See, that's the only thing. We simply find the f of s and then simply put an s in the denominator. That's all. Very easy, right? Let's do one more question. Find the Laplace transform of integral 0 to t into cos h t dt. Okay, let's do this question also. Integral 0 to t into cos h t dt. Okay, so here first I need to find the Laplace transform of this function, right? T. See, one more thing also. See, in these kinds of questions, right? If you see these kinds of complicated questions, You see, don't substitute the value of cos h t as the other equation that you have studied. That is, which equation? That is s by s square minus 1. Okay, don't substitute that equation over here, because that equation might be confusing for you, because after that it will be very difficult for you to find the integration unless you have to be an expert in integration. Okay, the best thing is, what you need to do is substitute the value of cos h t with that other function which you have studied, which is the exponential function. From there we can take on the values. Okay, which means that I'm trying to find the Laplace transform of t into cos ht, right? But what is cos ht? This can be also written as Laplace transform of t into, so what is cos ht? Cos ht is actually e raised to t plus e raised to minus t by 2, right? This is the Laplace transform of, this is the value of cos ht. That's what I said. So don't substitute the value early itself. Just simply you can do like this, right? Or what you can do is, you can substitute the value of cos ht and then you can apply the multiplication by t formula, multiplication by t property. Two ways you can do the same question. Okay. Anyway, let me try this method. So this is equivalent to Laplace transform of, that is Laplace transform of t into e raised to t by 2. Okay, Laplace of t into e raised to 2 by 2 plus Laplace transform of t into e raised to minus t by 2. Okay, or this can also be written as 1 by 2 the Laplace 1 by 2 into Laplace transform of e raised to t into t plus, and over here it is 1 by 2 into the Laplace transform of e raised to minus t into t. Okay, so in that case 1 by 2 into, what is the Laplace transform of e raised to t into t? The Laplace transform of t is 1 by s square, so this is nothing but 1 by s minus 1 the whole square, frequency shifting theorem, plus 1 by 2 into, what about this? This is nothing but 1 by the Laplace transform of t is 1 by s square, so therefore the Laplace transform of e raised to minus t is nothing but 1 by s plus 1 the whole square. There you go. See, easily I found the Laplace transform of this function. Okay, using which all Theorem property I used? I know that Laplace transform of t is 1 by s square. I used that property. The other property is the frequency shifting property. I combined these two property and I found the two values. Okay, this is one and this one over here. So now I found the Laplace transform for this. So now the answer is very easy, right? Simply divide this entire equation by s. That's your answer. So therefore, that is the Laplace transform of integral 0 to t f of t dt is actually equal to f of s by s, right? So therefore, the Laplace transform of integral 0 to t into cos h t dt is equal to, divide this whole thing by s, right? Divide this whole thing by s. So what you will get? You will get 1 by 2s, 1 by 2s into 1 by s minus 1 the whole square, 1 by s minus 1 the whole square. Okay, plus here it will become, here is also 1 by 2s into 1 by s plus 1 the whole square. See, so this is your answer. Simply divide this f of s by s. That's all. Very easy, right? So now let's do, I'm going to do the same question what I did in the last video, but this time I'm going to use multiplication by t property, just so that you can familiarize it. So I just wanted to show you that there are two ways of doing this problem. Okay, so the one way is that I substitute the value of cos h t as the exponential function. Okay, now what I'm going to do is I'm not going to do that like that. I'm going to go for the little bit slightly complicated method, but also useful when it comes to these kind of problems. Okay, the thing is, what I'm going to do is, first what I'm going to do is I'm going to use all the properties what I've studied before. So first property, I know that the Laplace transform of cos h t. Okay, let's look how we do this problem. The Laplace transform of cos h t is nothing but, it will be cos h omega. The Laplace transform of cos h omega t is nothing but s square, s by s square minus omega square. So here it will become s by s square minus 1. right? This is the Laplace transform of cos ht. So if the Laplace transform of cos ht is this one, then we know that the Laplace transform of t into f of t, right, is equal to minus of d by ds of f of s, right? Minus of d by ds of f of s, which is nothing. This is called as the multiplication by t property or frequency differentiation theorem. So here the Laplace transform of t into cos ht is equal to, simply differentiate this, right? That is minus of d by ds of s by s square minus 1. Okay, so this is where the complication comes. Now we need to differentiate this. Okay, so this is equal to minus of d by d, no need to write, let me substitute that over here. So this is, what is this equal to? This is u by v, so which means the equation is v into du minus u into dv by v square. So v into du, right? So v is s square minus 1 and u is equal to s, therefore du is equal to 1 minus, so v into du minus u into dv, so u is s, and dv, v is s square minus 1, therefore dv is 2s by v square, s square minus 1 the whole square. Okay, this is also equal to minus of, let me see, this will get s square minus 2s square is minus s square minus 1 by s square minus 1 the whole square. If I put minus inside, this is nothing but s square plus 1 by s square minus 1 the whole square. Okay, this is what I get from here. So now I can say that the Laplace transform of integral 0 to t into cos h t dt is equal to f of s by s, which is equal to s square plus 1 by s into s square minus 1 the whole square. See, if you compare this answer and the answer you just got in the previous video, actually both the answers are correct. Okay, both the answers are correct. The other, in the previous answer I did not combine the two terms, but once when you combine the two terms, you will get, definitely you will get this answer. Okay, so this is the another way of doing this question. Okay, if you want, we will do one more question based on this approach. So that's just so that you can be familiarized with yourself. Okay, now which method you like to choose, that depends on which is what your taste is. Okay, I would prefer the other method if you are not very good in differentiation. That's what I would suggest. Okay, I would definitely go for the other method if you are looking for an easy approach. But the only thing is that it takes a little bit more time. But here I applied all the properties I know. Okay, all the properties I know. So the steps are minimal. The steps are very small. But the only thing is that you should learn to do differentiation of slightly complex functions. If you can do that, then this method is okay. Okay. So now let's do this question. Okay, that is, find the Laplace transform of e raised to minus 4t integral 0 to t into sine 3t dt. Okay, see, so when you look over, once when you look at this question, you might think this is a very complicated question, but this is not a complicated question. This is a very easy question, because since if you know all the Laplace transform of all the basic functions and if you know all the properties, then this question can be solved within few steps. Okay, within a single page itself I can solve this question. Let's do this question. So here the first what I'm going to do is, we all know this equation, we all know the Laplace transform. First I'll start with the Laplace transform of this. Okay, the Laplace transform sine 3t. We know that the Laplace transform of sine 3t, okay, is nothing but, that is Laplace transform of sine omega t is actually omega by s square plus omega square. Therefore the Laplace transform of sine 3t is 3 by s square plus omega square, omega by s square plus omega square, therefore 3 by s square plus 9. Okay, now what I'm going to do is I'm going to multiply this with t. So therefore we know that the Laplace transform of t into f of t. Okay, see, for these kind of questions, whichever property are you using, it is always good that you mention those properties in your answer sheets. It is every time it is very good. Whenever you are trying to find the Laplace transform of these kinds of functions, it is very good that you always write the properties of whichever properties you are going to apply, because there you can score more marks. One thing is that because it will increase your step marks, and another reason is that you will never get the chance of making mistake. You will never make that problem making a mistake, because if once you have those properties, then you can look at those properties and substitute those values. That's why. So here the Laplace transform of t f of t is nothing but d minus of d by ds of f of s, right? This is called as the multiplication by t property or frequency differentiation theorem. So here in that case, the Laplace transform of sine t into sine 3t, right? The Laplace transform of t into sine 3t is nothing but minus of d by ds of this 3 by s square plus 9. Okay, so this is nothing but, let me see, this is nothing but minus of 3 into d by ds of 1 by s square plus 9. Okay, so this is nothing but, again this is also equivalent to minus 3 into, now what is the differentiation of this? That is this is s square, right? So differentiation of s square plus 9 becomes 2s plus 0, so it becomes minus 2s plus 0. So this is minus 2s by s square plus 9 the whole square, or this is equal to 6s by s square plus 9 the whole square. This is the Laplace transform of this. Okay, using this problem, multiplication by t, I used this. Next, I'm going to use the I'm going to use the time integration theorem. That is, we know that the Laplace transform of integral 0 to t f of t dt is nothing but f of s by s. Therefore, the Laplace transform of integral 0 to t into sine 3t dt is actually equal to 1 by s into what is f of s? This one, 6s by s square plus 9 the whole square, or this is nothing but 6 by s square plus 9 the whole square. Okay, so this is the answer. Now if you look over here, it is now the same functions multiplied by e raised to minus 4t, right? We also know that the Laplace transform of e raised to minus 8t f of t, the Laplace transform of e raised to minus 8t f of t is nothing but f of s plus a. This is called as the frequency shifting property. Right? This is called a frequency shifting property, and here the value of a is 4, right? So which means the Laplace transform of e raised to minus 4t into integral 0 to t into sine 3t dt is nothing but f of s plus a, which means replace every s with s plus a, and here the value of a is 4. Value of a is 4 over here, right? So this is nothing but 6 by s plus 4 the whole square plus 9 the whole square. This is the answer. Okay, if you want you can actually you can expand this term if you want. Okay, but I would prefer you write like this. Okay, if you want to expand, I'll expand it for you. So this will become 6 by this is s square plus 8s plus 16. So this is becomes s square plus 8s plus 16 plus 9 is 25 the whole square. Okay, there you see. So within a single page, by this is such a complicated function, such a complicated time domain signal, instead of, I mean, if you're trying to find the value of this, it will be very difficult to find it if you apply this in a straightforward manner, right? If you're applying that basic equation, that is integral f of t into e raised to minus st dt, if you're using that equation, it will be very difficult for you to find the Laplace transform of this, right? But since I already know the properties, how many properties did I use? I used 3 properties, if I recollect. That is, I used the multiplication by t property, then I used the time integration property, then I used the frequency shifting theorem. See, I used three properties. I used three properties to solve this question, right? This is how usually the questions in Laplace transform can answer. They'll give you a function and you can use any properties in any way you like. You can use their properties to find the Laplace transform. Okay.